Okay, rational exponents. They follow all the normal exponent rules in their way of writing nth roots. So some of the first things that you're going to do is you're just going to write a rational exponent in radical form. So take a look at the x to the 1/6. It just becomes x to the 6th root. So your denominator is your index. And if you go back the other way, if you have the 3rd root of w to the 2nd, then that becomes the rational exponent of w to the 2/3. So the exponent on the inside of the radical is the numerator, the top of the fractional exponent, the rational exponent. And so your index again is the denominator. If you're going to evaluate a rational exponent expression, 81 to the -1/4, always your negative exponents go take your whole base to the bottom of a fraction, so that becomes 1/81 to the 1/4 power. Write that rational exponent as a 4th root. So you have the 4th root of 81, and then you can evaluate that. And you've got, take that 81 down to a power, so 3 to the 4th power, and you can evaluate that. So you've got that 4th root of 3 to the 4th. And so that index cancels out that 4th power. And so you just have 1/3. And if we were to evaluate 216 to the 2/3 power, you can write that as a radical. I've got that green star because you have two options. You can write it as that 3rd root of 216 to the 2nd power. If you did 216 to the 2nd power, it would be an extremely large number. You can also take that power outside of that 3rd root. So you can do the 3rd root of 216 and then square that answer, which is your better option in this case, because you can do the 3rd power of, the 3rd root of 216, because 216 is 6 to the 3rd, which your index and that 3rd power, of course, cancel. So you end up with 6 squared, which is 36. So sometimes you have a different option. So there are other times when the number to the power works better for you, up there where you have the 3rd root of 216 to the 2nd. And in this case, it works better to have it raised outside of the root. Then we just have simplifying rationals. So what do you do when you multiply like bases? You add their exponents, so a to the 2/7 and times a to the 4/7. You add those exponents and you get a to the 6/7. Nothing more you can do there. B to the -5/6 is 1/b to the 5/6. And if you write that in radical form, you have 1/6 root of b to the 5th. You need to rationalize that. How many more 6th roots of a b do you need to be able to take that 6th root out? You need one more b. So you have the 6th root of b to the 6th. If you multiply out by a 6th root of b. And so that leaves you with just the 6th root of b on the top over the whole b. And finally, just rationalizing if you have rational exponents at the top. Again, you need a conjugate. You keep your two terms. You're changing the sign, which is really you're changing the sign of the second term. So instead of a +2, you have a -2. And you're multiplying top and bottom. You know, mathematically what's going on here is you're multiplying your original fraction by a fraction of 1, because that 3x to the half minus 2 over 3x to the half minus 2 is 1. If you multiply by 1, you're not changing anything. So anyway, as you multiply through and you do your distributive property, here's what you come out with. And on the bottom, you get those two terms that cancel out. And they're totally, it looks like the same term, but you have opposite signs. So the same thing, minus and plus, cancels out. I'm getting hung up on one step. Distributive property, just simple. X to the half times 3x to the half. You add those exponents, you get 2/2. So you got 3 to the x 2/2, which is 3 to the 1st, or 3x to the 1st. So you end up with 3x in the final step. And then you get 2x to the half, and you get 6x to the half. negative, and so you get negative 8x to the half, and you get your 4. And on the bottom you can't do anything else, you just get 9x minus 4, because that's 9 to the x 2 over 2, because you did 3 times 3, x to the half, x to the half, and that was adding those exponents again, half times half plus a half, so you get 2 over 2. And that's it. That's how you do a conjugate, and that's how you rationalize there.